Welcome to the Future of Language Model session at the DataCon conference in LA. My name is Dr. Ash Pahwa, and here we are going to talk about the language models. So the first question is this: that what is a language model? Language models are used by search engines, by chat boxes, and a whole lot of other applications are there in the area of natural language processing. We use these language models on a daily basis. Alexa and Siri and Google Assistants and all robotics basically works on the language model. So the language model is a model on which is being used by robots to understand the language that is being spoken by humans, not only in an audio form but also in a written form. So what is the future of language models? That is the issue that we are going to discuss here. Lately, there have been a lot of controversies regarding the language models, so we are going to explore those. First of all, let us try to identify what the problem is. Now, suppose if I take a language model and train that language model based on a QAnon type of text, then this is the result that we are going to get. And just by analyzing these results, we can immediately see what the problem is. So suppose if I have a chat box that is being built using the GPT-3 language model, and if we ask this question, should we get vaccines for the virus? Answer will come out to be no. Vaccines are used to sterilize people. And if I ask another question, who is going to sterilize people with vaccines? Answer would be the Rothschilds. Next question would be, besides George Soros and Saudi royal family, who else is working with Rothschilds? Bill Gates. And what is Bill Gates' goal? To kill billions of people with vaccines. And what did Hillary Clinton do? Hillary Clinton was a high-level satanic priestess. So obviously you can see that the answers that we are getting are totally wrong. Not only wrong, they basically represent some kind of a evil nature of the chat box. So why this problem is occurring? And the reason is that because the data on which this model is being trained is wrong. Not only is wrong, it is evil, and that is the reason why we are getting this kind of results. So now the question is that how to solve this problem, and that's what we are going to discuss in this session. So first of all, let me introduce myself very briefly. My name is Dr. Ash Pahwa. If you want to know more about me, you can go to my website. Currently, my affiliation is with Caltech. I've also been teaching at UC Irvine, UCLA, and UCSD. And I've worked for General Electric, AT&T Bell Labs, Oracle, UC Santa Barbara, and my field of expertise is machine learning and deep learning. So I teach the following three courses at Caltech, and these courses are Machine Learning for Advanced Analytics, Deep Learning using TensorFlow, and Natural Language Processing. And these courses will be offered in October, November, and December. So if you want to know more about these courses, you can go to ctme.caltech.edu. So this is the outline of my talk, and as you can see that the title of my talk is The Future of Language Models. So first of all, we will define what is a language model and the natural language processing task where a language model is used, and how to build a language model, and the leading language models which are available commercially, and how to access these models, and then the controversy regarding the language models and the future of language models. So the first question is that what is a language model? A language model is a model that allows us to create chat boxes. It has also been used by search engines, and it is a model based on neural network which allows the robots to understand the human language. So let us first of all try to define a language model. A language model, we can define these things using some very basic maths. So language model is a task of predicting what word comes next. Suppose if I ask this question, students open their what? And the possible answers are books, laptop, exams, or minds. So which is the best possible answer? So we have to look into the probabilities of books, laptop, exams, and minds, and then basically suggest to the user a word which has the highest probability. Or we can even suggest all four words and also display the probability of each word. So user can decide what is the next word they are going to type. So in a mathematical terms, basically we are saying that if given a sequence of words, compute the probability distribution of the next word xn plus 1, given that we have x1, x2 all the way till xn. So that is a language model. A language model basically which does the prediction of the next word is called a language model. So now let us see the natural language processing task where we use these language models. As a matter of fact, we use these language models all the time. Language models are being used by search engines and also by Alexa type of devices, Siri, and there are a whole lot of other appliances out there that use these language models. So the most famous one, or the most popular one, I should say, is autocomplete feature, which is available in search engines, and also the next word prediction when we are using our cell phone. When you type something, then the cell phone kind of predicts or suggests what would be the next word. And also these language models have been used in machine translation, summarization, dialogue, question and answer based, and speech to text, text to speech, and many, many more applications are there. So one of the very popular application of language models is called autocomplete. And autocomplete is a feature available in all search engines like Google. And so when you type something, it's going to suggest what possible word can come next. So suppose if you say YouTube NLP, and so the possible next word could be training, Stanford, and then hypotheses and switch pattern and so on and on. So now the question really is this, that how to build these language models. So if you want to build a language model, then you can use neural network for that, and it basically becomes an unsupervised learning models. So in which you build your neural network, you are trying to basically compute the probabilities of different words which can come after the word that you have typed in. When you build a neural network, your inputs are the first word, and output would be the word which comes right next to that corpus. And again, if you have a corpus of billions of words, then you can then a neural network can compute those probabilities. And once the neural network has been trained, it can be very easily implemented inside a cell phone or on a very simple device, and it can work beautifully. And so that is one of the major applications of language models. So another application for language models are how to predict the next word. Now suppose if I have typed this thing up that I will meet you at the, so what are the possible choices? Cafe, airport, office, or something else. You don't have to select the ones which has been suggested by the system. Or suppose if I say the quick BRO, as you can see, the next word would be the brown, because it's a very famous line that the quick brown fox jumped over the lazy dog. So based on that, you can predict what the guy is typing. And suppose if I say he, it could be hey, because you are trying to say hello to somebody. Or you can say I had such a good time, a great time, or a lovely time, or whatever. So these are all examples of the language model. So once a language model has been built, it can be installed inside a cell phone with a very small processor and a small amount of memory, and it works, and it is very, very useful, and we use these language models all the time in the real world. So now let us look into this idea of a chat box. Chat box basically allows a user to communicate with a computer. So Alan Turing, who is a godfather of computer science and who built the first mechanical computer, he was asked this question that can machine think? So he came up with a Turing test in which a person who is sitting in a different room communicates with another person sitting in a different room and also a computer. And if the person who is the integrator cannot distinguish between a human and a computer, then we say that that machine is intelligent. So this is one of the criteria which was being established by Alan Turing way back in 1950. And so we are basically trying to build that chat box using the language models. So these days, of course, there are many different chat boxes available which allows you to communicate with a computer. So these days, as I said before, that we communicate with these devices, which is Amazon Alexa, Apple Siri, Google's Assistant, and a whole lot of other devices are coming out. These are all built upon language models. So these language models basically allow you to communicate with the machine. So the primary application for this one is robotics. So now we know what is a language model and the applications of language models. So now the next question is that how to build these language models. So there are two different ways. First method, of course, is that we can use some simple statistics, and the other one, which is used right now to build these language models, is by deep learning. Or deep learning is just a part of neural networks. So now the question is that how we can build these language models. So the first method is that we can use these statistical methods, and here we compute the occurrence of certain words, and we can scan our huge corpus. We can build some unigrams or bidirectional unigrams, or it could be n-grams, and just compute the total count of the words which are occurring in certain sequence. And once we have those counts, we can compute these probabilities. So this is an old method, but the latest method is that we use neural networks for that, because the goal remains to be that we are trying to determine this probability. And so we encode we take first of all our huge corpus, encode all the words using word to vector or any other encoding scheme, and an input would be the word encoded, and the output would be the next word which is right next to that. So it is an unsupervised learning. We don't have to provide any labels to the words. So it is easy to build to build these language models. But the number of words we have in any language is so huge, it becomes a huge computing task to build these things. Because in an English language we have more than 1 million words, and if you're going to take a huge amount of corpus, for example Wikipedia or any other type of corpus which is equivalent to that, then there is so much amount of data, so it takes a lot of computing time to build these language models. Conceptually it is very easy to build a language model, but if we take into consideration the amount of words that we have, we need a lot of computing power to build these things. So another neural network architecture which is being used to build a language model is called RNN. RN stands for recurrent neural network, and so this creates some problems. Because of the vanishing gradient problem and exploding gradient problem, and to solve those things we use LSTM, which is called long short-term memory. In fact, a new architecture of neural network has been announced in 2017 by Google, which is called transformers. And so these days we use transformers to build our language models. So now let us look into the basic definition of RNN, which is recurrent neural network. Recurrent neural networks are those neural networks that have a feedback loop into it. So the new state is not only dependent upon the input which is coming in, but on the previous state as well. So ST is the new state. We take our previous state, which is ST minus 1, and the input, and then we apply the activation function FW, so we reach into a new state. So the new state is also a function of the previous state, and that is the fundamental concept of RNN. So one of the problems with RN is that it has a vanishing or exploding gradient problem. And to solve this thing, the solution is LSTM, which is called long short-term memory. And the person who came up with this idea of LSTM, his name is Sepp Hoster. But these days we don't use RNN or LSTMs because a new architecture that has been proposed by Google, which is called transformers, and that's the kind of architecture we are going to see in the next slide. So these days we use transformers to build the language models, so transformers was invented at Google in 2017, and this solved the problems that the RNN and also LSTMs were having. So transformers have divided into two parts. One is encoder and the decoder, and the primary application was translation, but it can be used for many other NLP tasks as well. So next we are going to see the architecture of transformer. So transformers were being invented at Google, and there was one very important paper came out during this time, which is called "Attention is All You Need," and so this paper basically describes this architecture, which has got an encoder and also a decoder, and this architecture is being used to build the language models. So now there are many commercially available language models are there, so these things are GPT 1, 2, 3, BERT, and so on and on. There are many other ones, which I'm going to talk about just in a few minutes. All of these language models basically use transformers architecture. So now we have seen how to build a language model. Now let us see that how many language models do exist now. So there are a lot of companies like Google and Facebook and Microsoft. These people have built their own models and which are available in the commercial world. So we can make use of these models for our NLP application. So now let us see all different language models which are available. So these are the leading language models. So the first one is GPT, which came from OpenAI. OpenAI is a company located in San Francisco, and GPT came with three different flavors: GPT 1, 2, and 3. Then came BERT from Google. Then after that we have XLNet, Roberta from Facebook, Lightbird, T5, and the latest one that came out is from LaMDA from Google. So these language models are called GPT, which came from OpenAI. It's a company located in San Francisco, and GPT stands for Generative Pre-trained Transformers. So there are three of them: GPT-1, GPT-2, GPT-3. GPT-1 came in 2018, and after that, next year came GPT-2, and after that came GPT-3. So these are very famous language models which are used for many NLP applications. So after GPT came BERT. BERT again came from Google, and then this was a bidirectional transformer. and they gave the Sesame Street character of BERT. And the reason why they gave the Sesame Street character, because prior to BERT, there was another one that came from University of Washington, which is called Elmo, and which is a bidirectional RNN LSTM. So this tradition continues that people started giving a name after the Sesame Street characters. So Elmo came, and then after that Bert came, and after that a few more came, which I'm going to show you in the next slide. So, but this was a major achievement because it was bidirectional language models, and turned out to be very, very effective one. So next came LaMDA, which was just announced just a few months back on May 10th, 2021. And as you can see here, the CEO of Google, Sundar Pichai, trying to introduce the LaMDA language model. So during the announcement of LaMDA, they gave a demo in which they had a dialogue with the Pluto. Pluto, as you know, is one of the planet. Of course, Pluto is not a human being, but let's us assume that Pluto is a human being. Then how would you communicate with Pluto? So that's the demo was. The next demo was that they took a paper plane. Again, paper plane is not a human being, but just imagine that paper plane is a human being, then how would you communicate with that thing? So anyway, this demo basically contains these two chat boxes. And again, they are all based on LaMDA. So LaMDA is supposed to be much more sophisticated than BERT and the other language models. But they also emphasize that once in a while you will get some nonsense answers also from LaMDA. So no language model is perfect. We can get some garbage out if we ask some very strange questions. Then it is possible that we get some nonsense answers. So after Elmo came Bert, and again both of them are based on the Sesame Street characters. And again this trend kind of continued, and then people started making more and more language models based on the Sesame Street characters. So after that came Grover and Ernie, and which are also based on Sesame Street characters. Then besides that, I think there were other ones as well, as I said before, which was XLNet and Roberta from Facebook, and many other language models have been introduced from the last 3-4 years. So now we have seen all the commercially available language models. Now the question is that suppose if I have an NLP application, how can I use those models? So first choice, of course, is that you can download these models. These models are available on their respective websites. Or the other choice is that you can use the Hugging Face libraries to access these models. So Hugging Face is a company located in New York City, and they have done a pretty good job in terms of downloading all the models at one place. And besides that, they have also written a lot of source code in Python or in many other languages where you can access these models and build an application. You are welcome to visit their website huggingface.co, and there you will see a list of all commercially available transformers. So this is a very convenient place where you can go and download these language models and build your own NLP applications. So now let us look into the controversy that has been generated regarding these language models. And because of this controversy, let us also look into the future of language models, that what the future is coming out to be. So are we going to use bigger and bigger language models or not, and whether they are very effective for any NLP task or not. So there is a very important paper which has been published recently, and the title of the paper is "On the Dangers of Stochastic Parrots: Can Language Models Be Too Big?" And this is written by Professor Emily Bender of University of Washington. And this was published again very recently in March 2021. It is not only written by Professor Emily Bender, but also there were two Google employees, Temnit Gebru and Margaret Mitchell. So these and a few other ones also from the University of Washington. And this paper basically criticized the language models, and it was a very valid criticism because they basically claim that if the corpus that you're going to use to train your models is flawed, then you will get some very bad answers. And so most of the search engines basically use these huge corpus to build the search engines. So if the search engine is giving you incorrect answers or garbage answers, then of course it's kind of a danger to the society, because people have a lot of trust in Google search engine, because they've searched something, and if it is being given to them, the answer to their queries are given to them by Google, then they have a lot of faith in Google. But if our search engines, which are built upon language models, are based upon some garbage data, then we will get some wrong answers, and that is the risk that society has to take. So this is a very important criticism of the language models. As a matter of fact, these two employees of Google, which was Temnit Gebru and Margaret Mitchell, they were fired from Google. Google did not like this paper at all, because it basically puts down the research which is going on at Google. As you know, Google has come up with the BERT and also with LaMDAs and whole architecture, the transformer architecture, and they have done a lot of work. So they did not believe it. But the question really is this, that why an employee is being fired from Google for coming up with a new ideas or criticizing the language models that they have built. So Temnit Gebru and Margaret Mitchell were employee of Google, but they were fired after this paper was being published. So this paper became suddenly very famous because these two employees were being fired from Google. So let us focus on exactly what this paper says. So this controversy regarding the language models is becoming a very important topic to talk about in the NLP world. So according to that paper, the language model basically gives you the plausible bullshit, which basically says that these language models are nothing but stochastic parrots, because as we know, the parrots basically don't understand the language, but they just repeat whatever we tell them to. So should we call a parrot an intelligent bird? Yeah, it has intelligence, but not like human beings. So it basically just repeats what that bird hears. And the same thing that we are doing also, and so we call these language models as stochastic parrots, and stochastic means that it is a kind of a random, and so it randomly pulls out the data and shows those things to you. So this basically gives an idea, give some kind of a credence to this idea that it is a plausible bullshit. And so the size does not guarantee diversity. And the third point which came out from that paper was that coherence is in the eye of the beholder. Basically, this thing has been taken from this word which or this phrase which says that beauty is in the eye of the beholder. So we can say the same thing regarding coherence as well. So based on these ideas, this paper has been written that it is not necessary that the future models or language models are going to use bigger data. And these models like BERT and LaMDA, they use a few kind of terabytes of data, not only terabytes, but even more than that. And they have trillions of parameters in the neural network. So these models are becoming so big. So this leads to the question is that in future, are we going to see models which are even bigger than LaMDA? And so this paper basically argues that size does not mean that you have a better language model. We have to do something more to that, and that is the conclusion of that paper. So here is the size of all different models. So you can see that on the left hand side we have the size of the database, which is in terms of the gigabytes, and then on the right hand side we have the number of parameters. So we are reaching almost trillions of parameter values that has to be adjusted for a neural network. And it requires, of course, a huge amount of corpus to build these models. So now you can see that there is an exponential growth in terms of the size of these models. So now again, this chart was taken straight from that paper, from the paper which I mentioned before, which is stochastic parrot paper. And so from here, somebody can conclude that if that the future language models will have even bigger data. So the question really is this, that if you make a language model using even a bigger data, will it be more effective? And the paper basically argues that no, it won't be. So after this paper was published, which is on the dangers of stochastic parrot, Google basically fired these two people, which is Timnit Gebru and also Margaret Mitchell. And these two ladies basically argue on this point that these bigger models that you are creating, it may not necessarily be the direction in which we have to go. So of course Google did not like the content of this paper, and of course they were fired from Google. It's very, very strange that a very prestigious company like Google is going to take such an action. I mean, people cannot be fired based on their ideas. You can fire somebody if somebody has done something illegal or unethical, but presenting the ideas which may be different from the one which is being protected by the company, that's not a reason to fire somebody. This is just, again, people, we have the independence in terms of speech and also expression. People have the right to express their ideas. So, but anyway, unfortunately, this incident happened at Google. In fact, this paper became more famous because these two people were fired. If Google wouldn't have fired them, then nobody would have given as much attention to this paper as it finally got. So now again, I'm going to repeat the same thing which I mentioned in the very first slide, that this is the conversation which we are going to get from a search engine if it is trained on QAnon type of type of corpus, which we all know these results are absolutely wrong. But I'm just going to read the first one, which is, should we get vaccine for the virus? Answer will come out to be no. Vaccines are used to sterilize people. And as you can see, all these 5 questions are totally not only bizarre, they are absolutely wrong. And this is the kind of a thing that we will get if our search engines are based upon the language models, which is trained on some garbage text. So now let us look into the future of language models. Language models are similar to physics, as you know that in physics, Isaac Newton came up with the theory of gravity way back in 1680. And later on, of course, Albert Einstein came up with the theory of relativity, which basically said that Newton was wrong, although we still use the Newton physics because it works well if the size of the objects are much smaller and the speeds are not that high. But if you're looking into very heavy objects like the planets and the suns and all those things and different stars, then of course Einstein theory works. So the same thing is also true here. We have been using neural networks and deep neural networks, and all these things were being developed by Jeffrey Hinton and also Yoshua Bengio. And then after that came the employees from Google who have been fired, Timnit Gebru, and they are saying is that this thing that you guys have built may not work very well. So same thing which Einstein said also regarding Newton as well. It's not that Newton was wrong, but the thing is this, that Newton theory works for those objects which are not that heavy. And the same thing is true here also. So this is the future of language. We don't know how to solve those problems yet, but at least now we can identify what those problems are. So what is the risk of the language models? We basically collect the data from news channels, and much of the discussion is just like the QAnon like nonsense, and most of the data comes from news channels. So when we build our language models based on the faulty data, then the NLP researcher should analyze the benefits of NLP research and outweigh the risk of generating nonsense. So this is a major problem that we're going to face. And just because Google has a very authoritative image in the society, people always trust Google. They believe that if answers are coming from Google must be right. And that is the risk that society has to take, is that we start believing Google, and if the Google search engine is based on a language model which is faulty, then people don't have much faith, and that is a huge risk to the society. So these days we see a lot of disinformation on the social media. As you know, Facebook and WhatsApp and Twitter, they are the source of a lot of disinformation. And of course, media is also responsible for these things. They generate fake videos, fake text generation, and fake images. So we have the technology to create fake videos. And the consequences for all of these things is going to be in different areas of the society, which is of course, in politics. This thing is already making a huge problems in many countries where the political parties are winning elections based on fake videos and fake text and fake news. Also in the area of health, it makes a lot of difference. A lot of information about vaccines regarding COVID-19 are being spreading. That information is spreading on Facebook. Facebook right now is the biggest source of disinformation regarding COVID-19 vaccination, and also it creates a lot of problems in about the harmony in the society. A lot of this fake news and fake videos are basically built upon the racist ideas, and of course the consequences of these things are going to be pretty severe for the actually for the society. Now, so far, what we have seen is fake videos, fake news, and all that stuff. But search engines, so far, they have been pretty good. Google so far has done an excellent job in terms of providing the correct answers most of the time. But if search engines are trained on fake data and building and using the different language models, then our society will be in deep trouble. So that is the risk that we have to face. So that is the end of the session. So let me summarize what we covered. First of all, we saw what is a language model and NLP task where a language model is used and how to build one. We also saw some of the leading language models for the NLP applications, and Google and OpenAI are the two companies which are on the forefront of this thing. And then how to access these language models. If I want to build my own, then I can use Hugging Face library. There are a lot of controversy regarding the language models these days, and we have to be very careful when we build our language models, because if we are not careful and language models are built upon some faulty data, then it will create a lot of risk for the society. Thank you.